All right, in this lesson, we're continuing to talk about inequalities in two variables, but today the focus is really going to be on graphing them, not just on the building blocks, but actually being able to graph a two variable inequality in the coordinate plane. So we want to be able to read and interpret the graph. So if it's already graphed for us, being able to look at that and identify what's a solution, what's not a solution, what's the equation of the boundary line, all of those things. We want to be able to graph it on the coordinate plane ourselves, and then we want to be able to write linear inequalities in two variables. So in example one, we're just kind of building up the important little pieces. So very similar to what we did in the last example for 16.1. So all of these inequalities are given to us in that slope-intercept form. So being able to identify, just like we did in the last example of the last lesson, being able to identify my slope, my y-intercept, and to decide whether the boundary line should be dashed or solid. So when we're looking at this in example 1a, remember that my m is what's attached to the x. So in this case, my m here is 2/5. Remember that that means that 2 is my rise and 5 is my run, and they're both positive. So this should be a positive slope rising to the right. The b value here is -5, which tells me that 0, -5 is my y-intercept. So that's helpful because this is my starting point, and then from my starting point, I can use my rise and my run. Remember, if you need to look back at the last set of notes, you can, but in those notes, we have it list out which ones form a dashed boundary line and which ones form a solid. And because this is a plane greater than, no equals, that means that this one would be dashed. So now if I look at my next one, my m value here would be -2, which again, I'm writing out additional info that would help me if I was going to graph it. That means that my rise is -2 and my run is 1, or my rise could be +2 and my run -1, or really anything that could reduce to -2. So if you wanted to rise 4 and run -2, you could. My b value here is -3, which tells me that my y-intercept is the point 0, -3, because remember, it's always 0, b. In this case, my symbol is greater than or equal to, which means that this should be solid because it has the equals. And when we have that equals, that's when we have a solid boundary line. Okay, so now looking at the next one, hopefully you've gotten good enough to try this by yourself, so just go ahead and try, and then I'll check it with you. So pause the video for a second if you need to. Write down your m, your b, write down what that tells you, and then circle whether we should have solid or dashed there. All right, so in this case, my m attached to the x is +2. So what that tells me is that my rise over run can be +2 over +1, or could be -2 over -1 if we want, or it could be 8 over 4 if we want. Anything that reduces to 2 is an acceptable rise and run. The b value here, it's positive this time. We have a plus, so b is 4, which tells me that my y-intercept there should be the point 0.04. This one, it's a plain less than, no equals, which means it's dashed. Okay, so hopefully if there were pieces there you didn't get right, you understand why the answer is what it is. We've practiced quite a few now. So this one you're truly going to answer on your own first. So go ahead for D, write out your M, write out your B, circle dashed or solid. So you're going to answer all of those pieces yourself here. All right, so checking your work, your M, hopefully you said, is -2/3, which again, for our meaning, that means that we could rise -2 and run +3, or we could run +2 or rise +2 and run -3. My B value is 1, which tells me that 0, 1, the ordered pair, is my y-intercept. And then, because it is a greater than or equal to symbol, whenever I have the equal to, that makes it a solid boundary line. Okay, so example 1 is our warm-up. Example 2, we're hitting back where we were at the end of 16.1, and we're actually going to graph the whole thing. So remember, and I'm going to write down the steps right up here. So step 1 is to plot the points for the boundary line. Step 2 is we are going to decide if solid or dashed to connect. And then step 3 is to pick and plug in a point to decide where to shade. And again, I'm not going to rewrite everything that we already learned in 16.1 because then what would be the point of doing that lesson first? But make sure you look back at that because I gave you a little more details as to what we're doing here in step 3 since we did that in the last lesson as well. So here in A, I am identifying, okay, this is my M. So my rise is -3 and my run is +2. This tells me that 0, 4 is my y-intercept. And this symbol right here tells me that when I connect them, it should be with a solid boundary line. So start with my y-intercept always. So 1, 2, 3, 4, right up here is where my y-intercept should go. My rise and run, it tells me to rise -3, so that means go down 3 units, and run 2, so that's to the right. So rise 3, run 2, rise 1, 2, 3, run 2, rise 3, run 2, and then that could also mean rise +3, so 1, 2, 3, run -2, as that would be on the same line as well. So we plotted the points on the boundary line. We already decided it should be solid, so we'll go ahead and connect it with a solid boundary line. Sorry, I missed a little connecting the dots there. Then step 3 is to pick our point. So as I said in 16.1, I typically pick 0, 0. The only time I don't pick it is if it's on the boundary line because you're not allowed to pick something on the boundary. So I pick 0, 0 and I plug it in. 0 less than or equal to -3/2 times 0 plus 4. And then I'm going to simplify. So I do the multiplication first. -3/2 times 0 is 0. Then I do 0 plus 4, which is 4. So the statement I'm looking at is 0 less than or equal to 4. Well, yes, 0 is less than 4, so this is a true statement. True statement means that you should shade where your point was. So the half plane that contains your point should be shaded. So in this case, 0, 0 is on this side of the boundary line, so I would shade over here. All right, next one, we take a look. We see that our M is -4. So that means that my rise is -4. My run is +1. The 5 here tells me that that's my B. So 0, 5 is my y-intercept. And then the symbol, plane greater than, tells me that I'm going to have a dashed boundary line. So to graph my boundary line, I start at the point 0, 5. So 1, 2, 3, 4, 5. It's right here. Rise -4, run 1. It's a pretty steep slope. I don't have enough room to go up 4, left 1 anyway, so I'll just continue going down 4, right 1. So 1, 2, 3, 4, right 1. And then I should be able to fit one more. 1, 2, 3, 4, 1. All right, so I plotted my points. Now I know my boundary line should be dashed, so when I connect them, I just kind of put little dashes between the dots to make it obvious that it is a dashed line. Now is the time where I decide which way to shade. So again, I would pick 0, 0 since it is not on the boundary line, and I would plug that in. So I'm plugging that in here. So 0 in both places, 0 greater than -4 times 0 plus 5. Your next job on your own is to simplify this, just like we did in the last lesson and just like we did over here. So simplify it till it's a statement 0 greater than something and decide if it's true or false. Remember that if it's true, we should shade the half plane with 0, 0, so kind of down and to the left. If it's false, we're going to shade the half plane where 0, 0 is not, meaning that we're going to shade kind of above and to the right. So you're going to finish this statement to see if it's true or false, and then you tell me whether I'm going to shade below and left of the boundary line or above and right of the boundary line. Okay, so hopefully when you simplified, first step was to do -4 times 0, which is 0. So then I've got 0 greater than 0 plus 5. 0 plus 5 is 5. So I'm looking, is 0 greater than 5? So no, this is false. 0 is not greater than 5. So since it's a false statement, I should shade where 0, 0 is not. So that means my shading should be up here, which is the above / to the right area. All right, so now we are going to take a look at examples where we don't have it in slope-intercept form. So you can do this a couple different ways. So I'm going to do D first, and then we'll look back at C for yourself. So because this isn't in slope-intercept form, it's in standard form, you have two choices. You can either pretend like it's an equal sign and use the cover-up method. So I'm going to try that first. So if I'm using the cover-up method, that means I pretend like it's an equal sign for right now. If I cover up my x term, that gives me -3y equals 6. So y equals -2, which means my y-intercept is 0, -2. Then when I cover up the y's, that would give me 2x equals 6, divide by 2, x equals 3, and so 3, 0 would be my x-intercept. So if I'm using this method, I would plot these 2 points, and then I would look at my symbol and I would say, okay, that means that this is a dashed boundary. And so I would plot these 2 points, so 0, -2, and 3, 0. And I would connect them with a dashed boundary. Now, the other method that you're allowed to use is the method where we put it into y equals mx plus b form. So meaning I'm going to solve this inequality for y. So if I do that, I start with 2x minus 3y is greater than 6. So my first step would be to subtract 2x on both sides. So that gives me negative 3y is greater than negative 2x plus 6. And then I would divide all of the terms by the negative 3. Now, the reason why it says be careful is you always want to check your solution, which we do when we pick our point, is because if you're solving here and you're dividing by a negative number, remember that with inequalities, when we divide or multiply by a negative, we have to flip the symbol. So this greater than becomes a less than. And so then I have negative 2 divided by negative 3 is positive 2/3 x, and then 6 divided by negative 3 is negative 2. So notice, if I do it this way, I'm still getting a dashed boundary. My m is 2/3, my b is negative 2. So I would still start at the same spot, and because my rise would be 2 and my run would be 3, I would get this same point, and then I could also plot additional points. So up to, sometimes so hard to see on this, up to right 3, or I could go down to left 3, down to left 3, and then connect with my dashed boundary line. So you see, you get the same boundary line regardless. The part where we have to be really careful is when you are plugging in your point. If you plug it in to this equation and you forgot to flip the symbol, you're most definitely going to shade the wrong way. I would suggest that even if you prefer this second method, which is totally fine, that when you go to pick your point, so again, I'm going to pick 0, 0, as I pretty much always do unless it's on the boundary, I would plug it into the original. Because yes, if you plug it in here, it should give you the same thing. But if you had made the mistake and forgot to flip, you're going to get the wrong answer. So if I plug in 0, 0 here, it'd be 2 times 0 minus 3 times 0 greater than 6. So this would be 0 minus 0 greater than 6. So 0 greater than 6, that is a false statement, which means I should not shade where 0, 0 is. That means I should shade the opposite way. So in this case, I would shade below and kind of to the right is where that half plane is. So hopefully that makes sense. You always want to check your solution by plugging that in and making sure that you're correct. All right, so on this last one, I want you to give this a try. So choose your method. It's a standard form just like in D. So choose your method. Either use the cover-up method to find both intercepts, or get y alone to put it into y equals mx plus b. The first thing I'm going to ask you for is what is your y-intercept? Because regardless of method, you should have identified your y-intercept. All right, so if you were using the cover-up method, then you have 2x equals 6, divide by 2, x equals 3, so your x-intercept is 3, 0. Then when you cover the x's instead, you get 3y equals 6, divide by 3, y is 2, so 0, 2 would be your y-intercept. So y-intercept here, x-intercept here. And this tells me that I should have a solid boundary line on this guy. If you chose the other method, then you're starting out with 2x plus 3y greater than or equal to 6. So first I would subtract the 2x. So that gives me 3y greater than or equal to negative 2x plus 6. Then I would divide everything by 3. Now notice this time I'm not dividing by a negative. So it's just y greater than or equal to negative 2/3 x and then plus 2. So regardless, I get a y-intercept of 0, 2. If I was doing the cover-up method, I would also have plotted 3, 0 and connected the dots. If I'm using my slope here, I would have gone down 2, right 3, which it does. Then I can go down 2 and right 3 again. Or I could also use my slope to rise 2 and run negative 3. So 1, 2, 1, 2, 3. Again, solid boundary line this time. So connect it with a solid line. Now we're picking our point. So again, if I pick 0, 0, that gives me 2 times 0 plus 3 times 0 greater than or equal to 6. So this is 0 plus 0. 0 is not greater than or equal to 6. So this is a false statement, which means I'm going to shade where 0, 0 is not. So in this case, kind of above and to the right. All right, very last one. Here, they have graphed for you, and you need to be able to use what you've learned to be able to write the inequality. So, if you notice, this symbol is less than, and my shading is kind of below. This symbol is greater than, my shading is kind of above. Greater than, above. In this case, once y is by itself, less than, below. So that can kind of help you in that, in general, when it's in y equals mx plus b form, greater than generally means shaded above, less than generally means shaded below. So what I want you to do is I want you to find the equation of the boundary line. I am telling you that what the symbol is going to be, and you are going to identify your M and your B. If you can't really tell where those exact points are, I'll put dots on them. So here's a dot right here, and here's a dot right here. That should show you what your rise and run are, as well as your y-intercept, so that you can finish what I'm going to start here. Dashed, which means it's a plane less than or plane greater than. This is shaded above. So that means that my symbol that I'm going to use should be a greater than or equal to. So I'm going to have y greater than or equal to, and then we need to fill out the mx plus b part. So figure out what your slope is, figure out what your y-intercept is, and finish the inequality here. All right, so hopefully you drew your little triangle here. And so my rise, which is right here, I actually moved down 3. So it's a negative rise. My run, I went right, which is positive, and it was 2 units. So my rise over my run is -3 over 2, and I've got my x, and then my y-intercept right here is the point 0, 3, which means my b is 3. So plus 3. Remember that you can check your answer here by plugging in your point. If I plug in 0, 0, I would get, so I'm just checking it, I would get 0 greater than or equal to -3/2 times 0 plus 3, which would be 0 greater than or equal to 0 plus 3. 0 is not greater than or equal to 3, which means 0, 0 should not be shaded if this is correct, and it's not. The other part is shaded, so I feel very confident in my answer here. All right, so hopefully you feel confident in being able to do the 3 steps here to graph your inequalities. Make sure that you reach out if you have questions.